Okay, worksheet 3. Here we go. Again, I didn't print this out for you. Copy this down, right? Copy worksheet 3, trig ratios, notes. These are the notes. Again, put this in your notebook, into your notebooks, right? Okay. And again, yes, I know it's only asking you for one here, but I'm asking you to actually find 3. You should be able to find all 3. And again, yes, we kind of been doing this for a while, but the difference here in this for this assignment is if you notice, see, there's a missing side. There's a missing side, and other than that, everything else you should know how to, you should know how to do these ratios already because we covered it. Okay, pause it, copy number 1, and then we're gonna start. Okay, hopefully you copied everything down. Worksheet 3, the directions, we're looking for sine, cosine, and tangent. And for these, if you get lucky, well, like number 1, which is going to be rare, but you never know. What you're going to want to do again is just, even before I even look at the one they're asking me to find, right? Because on the assignment, they're just going to ask you to find one. But what you want to do is, again, just same habit, same good practices. Label, right, the hypotenuse first, label it. Draw an arrow opposite of the angle, so that's the opposite side. And then finally the A, or the adjacent side, is the last one, right? And what am I talking about if you get lucky? Well, if you look at that one that they're asking you for, which I'll just do for this one. I'll just do one for this one, but I'll do all the 3 for the other ones. If they're just asking you for this one, and we know that cosine is ka, right? Because that's with a C, so that's cosine is what? A over H. And we can see here that A and the H are the ones that are there. I don't have to find this one. I don't have to know this side here. Usually, yes, you would need all 3. But if I'm paying attention here, I don't have to waste time finding this side. If I just have to find cosine, well, then I have it here. That would be what? That would be A, which is 12, over H, 13. And then that would be it, right? Because there's nothing to reduce. There's no square root. So we're done. Cosine is 12 over 13. If it's just the one individual one, maybe I think in your assignment that you just have to do one, okay, then, but most likely the one that's missing is the one you're going to need. So that's what we're going to see now in the rest of these problems. Okay, so watch here. Let's look at number 2. The only new thing now, again, because you know how to do the sine, cosine, this is the third, so you did number 1, worksheet number 1, you practice sine, cosine, tangent, and now you're doing it again. You did it on worksheet number 2, and now this is pretty much similar, except for the fact that there's one missing side. That's the only thing that's different. Okay, so what do we do when there's a missing side? We have to find it, right? We need that side. You don't have a number here. We have to find this missing side. Oops. Find the missing side. We're going to need it. So that's the new thing for today, which is not too big of a deal, not really new math. You've learned this before. For a right triangle, and you're given 2 sides, how do you find the third side? Well, you can use the, what? Pythagorean Theorem. I'll just write it one time right here. Pythagorean Theorem. All right, so, what is the Pythagorean Theorem? A squared plus B squared equals C squared. Remember? Saw that in geometry. Should have maybe even seen it in Algebra 1. And here it is again. For a right triangle only, if you have 2 sides and you're missing the third side, or to find the third side, you use this. And this is now where you have to what? Label these. Not as opposite, adjacent, or hypotenuse, but you're going to have to do what? Let me copy this over. I got 5 and I got 13. And here's the angle. We're not going to label them. You know what? Let me label them up here for the, with the O and the H and the A, right? This would be the H, the hypotenuse side. This would be your opposite side, and this would be the A. See, we're missing the adjacent side. I don't have that value. But when you're using the Pythagorean theorem, you actually have to not use O, H, and A. You have to go back to using what? A, B, and C. Anybody remember how to, which one's A, which one's B, or which one's the most important side? The most important side is C. The C is which side? A and B can be any other two, but the C has to be the what? The hypotenuse. A and B could be either one of the legs. All right, this is the hypotenuse, this is the legs. A and B, it doesn't really matter because you're adding them, but this one's the C side. So I'm going to make the missing side A, and I'll call that one B. And so you do the Pythagorean theorem, which would be what? A squared, right? I don't have A, so A squared plus B, which is 5 squared, equals 13 squared, right? A squared plus 25, right? 5 squared is 25. 13 squared is 169. Let me see. 13 squared. Yep. 169. Then you're going to get A squared is equal to, well, it's going to be 169. And then you move that positive to the other side. It would be minus 25. And then you're going to get A squared is equal to 144. And remember, I don't want A squared, I just want A, so you square root both sides. And A is equal to the square root of 144. And the square root of 144, you should have a calculator, you should hopefully know this by, is 12. So this is the side that we're missing. This A side is what? 12. I'll put it here. But honestly, I want to put it back over here where it has the O and the H and the A, right? So let's put it back to this one over here. 12. 12 is your adjacent, the value of your adjacent side. Okay, so now that you have all 3 sides there, see, now I got all 3 sides. Now I can find sine. Right, sine is opposite over hypotenuse, so sine would be so. Opposite over hypotenuse, sine would be what? Opposite is 5 over hypotenuse 13. That's sine. And then cosine would be what? Ka, A-H. 12, right? The A is that 12 we just found over hypotenuse 13. There's your cosine. Again, always look to reduce always check to reduce, but we didn't have to reduce anything here. And then finally, which other one? Tangent. Tangent is what? Toa, O-A. So that's O, which is the 5 over the 12. And again, nothing to reduce, so that is it. So that's it. You're still doing sine, cosine, and tangent. But the only thing is that for these triangles, you're going to have a missing side. Now, don't think that's it. Wait for these next two because you're going to have these with some square roots here. Okay. Number 3. As a matter of fact, I think it's just with one more is going to suffice. Let's see. Yeah, we've seen this before. I'll just do one more. Okay, number 3. We are going to, well, for this one, I'm going to, again, since I'm asking you to find all of them, we're going to go ahead and just do that first, actually, and just label this, right, for A squared plus B squared equals C squared. I'm gonna label first the A, B, C's because I'm always going to need that missing side anyways. Okay, so this is my C side. Hypotenuse is your C side. The A is there, and we'll call this one B, right? Okay, so that's going to be A squared plus b, which is what, 8? 8 squared equals what? C, which is 4 root 13. And I got to square that. Here's where you don't want to mess up, so do this step carefully. Here I'm fine with a squared is what? Well, just a squared plus 8 times 8 is not 16. 8 times 8 is 64 equals. Here's where students make a mistake and they drop the ball. If there's ever a place they drop the ball, it's right here. Don't skip, don't guesstimate, don't try to do this in your head. You know that 4 root 13 squared means a 4 root 13 times another 4 root 13. Which is really what? Well, I got a 4 and I got another 4. 4 times 4, I got this 4 and I got this 4. And then the square root of 13 times the square root of 13 makes a what? A whole 13. So you got to multiply 2 4s and 1 13. These 2 4s and the square root of 13 times the square root of 13 gives you 1 13. Okay, 4 times 4 is 16. 16 times 13, I got 208. A squared plus 64 equals 208. Move that positive 64 to the other side. That'll be a squared is equal to whatever 208 minus 64. 208 minus 64 is 144. Ooh, again, a squared is equal to 144. Then you take the square root of both sides. It's going to be a is equal to the square root of 144. Well, we just did one with 144. We got 12, right? All right, that means that this missing side is what? 12. I'll put it back over here. We know this side now is 12. Okay. Now for the trig functions, I'm going to keep this triangle. Let me copy it over. I got 12 here, I got 8 here, and I got 4 root 13 here, and my angle is here. Now for the trig ratios, you don't use A, B, and C. We use the opposite and the adjacent and the hypotenuse, right? So label those. Now that you have all three, label those accordingly. That is the hypotenuse. Opposite of the angle is the O, and the last one's adjacent. All right, and then from here, this looks very similar to what you did in worksheet 2, right? And worksheet 1 also. Finding the three ratios, that's going to be sine is so, which is O over H, which is 12 over what? Oh, the 4 root 13. We've seen this before. When you have a radical in the denominator, you got to fix it, right? Got to fix it. 12 over 4 root 13 cannot stay like this. So how do we fix it? You multiply top and bottom by the square root of 13. That's going to be what? 12 root 13 over 4 times what? 13. Right? Those two square root of 13s give you the whole number, and you got the 4 right there. That's going to leave you with 12 root 13 over 13 times 4. Or you know what? I'm sorry. Let's do this. I could just reduce right here. Everybody look, before I multiply these, why don't I just look at reducing this? Before I multiply the 4 with the 13, I can reduce the 12 and the 4. 12 divided by 4 is 3. So it'd be 3 root 13 over what? Over the 13. There's sine. Cosine is going to be very similar because what? Cosine is ka, which is A over H. Just like here you had the H on the bottom, guess what? We're going to have the same what? Scenario here. 4 root 13 over, in this case it's what? 8. Oh yeah, you know what? I didn't look at that. I should have reduced it right here before I even took care of this. That's right. You should have reduced this right here before you even try to fix this. So really your cosine is 8 divided by 4 is 2 on the top over root 13. Okay, now we fix this, right? Now we fix this. Cannot leave your ratio with a radical in the denominator. Multiply top and bottom by 13. That'll give you cosine is 2 root 13 over 13. And these can no longer reduce. Okay, last one, tangent. Tangent is going to be easy because that's TOA, O over A. Neither O or A have a radical, so it's going to be what? O is 12 over A, which is 8. But see, you can reduce that. You can reduce by 4. So tangent is going to end up being 3 over 2, right? Reduced by 4, divide by 4, divide by 4. There it is. Okay, so that is the new thing with this worksheet 3. It'll have one of the sides missing. Do Pythagorean Theorem, find the missing side, and then from there you can do sine, cosine, and tangent. All right, there it is. Good luck.